This is going to be an area volume type problem. This problem is non-calculator. For area type problems, where we're finding the area of a region and then also using that region, revolving that region to find volumes, one of the first things we should start with is drawing the representative rectangle. So, representative rectangle. The thickness of this rectangle is dx. The height of this rectangle is top curve minus bottom curve. Finding the area of R, we're going to integrate with respect to x, since the thickness of this rectangle is dx. Integrating from x value to x value, so from 0 to 9. Top curve minus bottom curve. Top curve is 6. Bottom curve is 2 square roots of x. Integrating with respect to x. Since this is a non-calculator question, then we're going to integrate by hand. The integral of 6 is 6x minus the integral of 2 square roots of x. We can rewrite 2 square roots of x as 2x to the 1/2. Increase the exponent, divide by the new exponent. When we increase the exponent, we get 3/2. Dividing by 3/2 is the same as multiplying by 2/3, so then we end up with 2/3 times 2, so 4/3. And then we're going to evaluate from 0 to 9. When I plug in the lower limit, it's just going to be 0. When I plug in the upper limit, 6 times 9 minus 4/3 times 9 to the 3/2. No need to simplify, so then I would stop there and I would move on to the next part of this question. The next part of this question says, write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the line y equals 7. Y equals 7 would be this line. So this is our axis of revolution. And this space between the axis of revolution and the region we're revolving means that this is going to be washer method. So then our cross-sectional area is going to be the area of this washer, a circle with a circle missing. Here's my axis of revolution. Let me redraw that. Here's my axis of revolution. Here's my washer. Here is the space between my axis of revolution and my representative rectangle. And so the way that I would find the area of a circle with a circle missing is going to be pi r outer squared minus pi r inner squared. The area of the big circle minus the area of the little circle. The area of the inner circle minus the area of the outer circle. So then pi times the outer radius squared. The outer radius is going to be the distance from the center to the outer circle, which on our picture is this distance. Top curve minus bottom curve, that's going to be 7 minus 2 square roots of x. And then squared. There's pi r squared, pi times the radius squared, minus pi times the inner radius squared. The inner radius is going to be the distance from the center to the inner circle, which on our region is this distance, which is just 1. So then I can write that inner radius either as 7 minus 6 or just 1. So there's the area of our cross section. We're going to integrate the area of the cross section. Since we're integrating with respect to x, we're going to integrate from x value to x value, so from 0 to 9. We can bring out the constant multiple pi. We don't have to. 7 minus 2 square roots of x squared minus 1 squared integrated with respect to x. This says write but do not solve, so we're done there. There's our outer radius squared minus inner radius squared. The common mistake here is for students to do outer radius minus inner radius, the whole thing squared, but we're finding the area of a circle with a circle missing. So that's area of the big circle minus area of the small circle. And then part C. Part C says region R is going to be the base of the solid. The cross sections are going to be perpendicular to the x-axis, or to the y-axis. So I'm going to erase some of this. So here's our new representative rectangle, perpendicular to the y-axis. So integrating with respect to y. Integrating with respect to y means two different things. It means that our limits are going to be y values. We're integrating with respect to y. It also means the function that we're integrating has to be y's. So if I do right curve minus left curve to get the length of that strip, then the length of the strip, taking this curve, solving for x, divide by 2, square both sides, x is equal to y over 2 squared. Still, we want to integrate area to get volume. This area is going to be area of a rectangle. So area of a rectangle, and not actually a rectangle, but a really thin rectangular prism, where the width of that rectangular prism is dy. And this base of that rectangular prism is the strip that's shown as the green representative rectangle. So these rectangular prisms are coming out of the page. The length of that strip is the value that we just found, which is y over 2 squared. The problem tells us that the heights are 3 times the length of the base. So this height is 3 times y over 2 squared. The area of a rectangle is going to be base times height. And then I'm going to integrate that area to get the volume. The base is y over 2 squared. The height is 3 times y over 2 squared. That's what we're going to be integrating. Y over 2 squared times 3 times y over 2 squared. No need to simplify. This says write but do not solve. So that's what we've done. We're not going to get any more points for doing any kind of algebraic simplification. So then no point in doing that. The only thing that could possibly do for us is lose points for us. The first point comes from having the correct integrand from part A. The second point comes from getting the correct antiderivative. The third point comes from having the correct answer, non-simplified. Our answer is non-simplified, but it's still the correct answer. For part B, 2 different points for the integrand. So did we get the outer radius squared correct and the inner radius squared correct? And then another point for having the limits and the constant pi, this constant pi, correct. So did we integrate from 0 to 9, and did we forget or did we remember to write the pi? And then for part C, did we get the integrand correct? So did we get that base times that height correct? And then did we set up the total integral correctly, which is to say we got the limits and we multiplied the base times the height. And that's the total, 9 total points.